Let's continue our discussion on radicals. Now let's look at finding the root of a variable. When we take the square root or any even root, we only receive the principal or positive root. Because of that, when we take the square root of a variable, we want to ensure that the variable is positive, so we put that variable in absolute value. Some examples: if we took the square root of 81x squared, we could consider this as 9x squared, but because we don't know if x is positive or negative, when we take the square root with the square, they cancel because they're inverse operations, but we need to put absolute values around the x to guarantee that the x is positive. For the next problem, square root of 16x squared plus 8x plus 1, we need to see if it's factorable. Square roots do not work nicely with pluses and minuses underneath them. I do not get to split this up with the plus and minus. And for a brief reason why, if you recall the order of operations, parentheses, exponents, multiplication and division from left to right, addition and subtraction from left to right, square roots, cube roots, any of the roots sit up here with exponents. And take a look at what's directly below exponents, multiplication and division. So these operations, exponentiation and multiplication and division, they interact nicely together. For example, if I go back to the previous problem, 81x squared, and I'm taking the square root, this is actually equal to the square root of 81 times the square root of x squared. I can break apart this multiplication and put square roots on each part. But it only works with multiplication and division because of their proximity in this order of operations. Taking a look at where addition and subtraction is compared to our radical, way too far away. I have to jump over the multiplication and division to get there. It's too far away. So exponents and radicals do not work as far as breaking apart a polynomial or an expression. I'm not allowed to break apart an expression with addition and subtraction between the terms if I have exponents and radicals. So long story, super short, this is not equal to square root 16x squared plus square root 8x plus 1. I'm not allowed to do this. Be mindful of that as you're working these problems. The only thing we can do is split it with multiplication and division. So I need to try to factor. 16x squared plus 8x plus 1. I can make my table AC and B is 8. A times C is 16. I need two numbers to multiply to be 16 and add to be 8. 1 times 16 doesn't work. 2 times 8 doesn't work. But 4 times 4 does. So that means 8x I can split into 4x plus 4x. And then factor by grouping. 4x in common, plus sign in the middle comes down. 4x plus 1 has nothing in common, so we'll leave it as 1, and the greatest common factor we pulled out. And then I see I have 4x plus 1, and the leftover bits, 4x plus 1, they are identical. So the square root of 16x squared plus 8x plus 1 is equivalent to the square root of 4x plus 1 squared. Because I have this plus 1 in there, when I take the radical and cancel with the exponent, right, the 2 and the radical symbol, I'm going to put my absolute value around the whole thing. The reason that I'm putting it around the whole expression instead of just the x is because of that plus 1 that's sitting there. Take, for example, if x is negative 1/4. If x is negative 1/4 and I plug it into our original function, if I plug in negative 1/4 into my original expression, 16x squared plus 8x plus 1, I get 0. And if I take the square root of 0, I get 0. If, for example, I had 4 absolute value x plus 1, when I plug in 1/4, negative 1/4 here into x, I end up with a positive 1/4 because it takes the absolute value. So 4 times 1/4 plus 1, I get 1 plus 1, which is 2. It does not match my original expression plugging in the same value. If I have addition and subtraction like I do here, I'm going to put that absolute value on the whole expression, because the whole expression in absolute value is what I need to be worrying about to make sure that it matches my original expression when I take the square root. If I did that same philosophy up here with the 9x and I put the absolute value around the whole expression, it's still equal because 9 is positive and I'm still forcing x to be positive. So this doesn't change anything, putting the absolute value on the x or not. But it will if I only focus on the x here because of that +1 on the outside. The +1 kind of changes the game for us. So let's put an absolute value around the whole expression when we take that square root, if there's a variable present. I want you to try number 7. You try part A. We'll do parts B and C together. So pause the video, try part A on your own because I think it's really good that you try it now, and then we can look at the other two problems together. When you simplified part A, did you get the absolute value of x plus 6? Good job. For part B, we're going to ignore the -2 out front and look at what could be squared underneath that radical, x squared minus 8x plus 16. Do some work off to the side, factor that binomial. We need two numbers that multiply to be 16 and add to be -8. I had a similar problem right above. It was multiply to be positive 16 and add to be positive 8. I needed two 4s. So this is going to be -4 when I factor. So again, if you need that moment to practice the factoring of this trinomial, take the time. Pause the video, do that factoring. We get x minus 4 squared. X minus 4 times x minus 4. The -2 sitting out front is just a multiplier. -2 times the radical x minus 4 squared. The radical and the square are inverse functions. They cancel each other out. But because that x is inside, we need an absolute value. So we'll say -2 times the absolute value of x minus 4. Do you notice anything different with part C? Part C is not an even root. It's an odd root. And since it's an odd root, we don't worry about the absolute value at all. The odd root of a negative number is negative, and the odd root of a positive number is positive. We don't have to use absolute values at all. So here, we just need to simplify. And we'll formalize this a little later. But we can look at this where the multiplying between, we can break apart this radical. Cube root of 125, cube root of x cubed, cube root of y to the 6th. And the cube root of 125 is 5. 5 times 5 is 25. 25 times 5 is 125. Cube root of x cubed is going to be x. And then the cube root of y to the 6th. Let's do this one out to the side. Y to the 6th is y 6 times 4, 5, 6. And since I'm taking a cube root, I need 3 groups. So cube root of y to the 6th would be the cube root of y squared to the 3rd power. I have 3 y squareds. The cube root and the cube cancel each other out, and we're left with y squared. So the cube root of y to the 6th is y squared, 5xy squared.